Hi guys, today I will say about the conversion from NFA to DFA. Every DFA is an NFA, so there exists an equivalent DFA for every NFA. If you go for the NFA, the delta is given by multiplying of Q into sigma, which gives us the 2 power Q. But whereas in the DFA, sigma is given as Q when we multiply Q into sigma. Here we can see that 2 power Q of the NFA is not a part of Q of the DFA, but Q of DFA is a part of the 2 power Q of NFA. Here we can say that every DFA is a subset of NFA. Contradiction between the DFA and NFA. When a specific input is given, then the machine goes to the multiple states. But whereas in the DFA, when a specific input is given, the machine goes to the only one state. In NFA, it can have 0, 1 or more than one move on a given input symbol. But whereas in a DFA has only one move on a given input symbol. Here we can say that DFA is very specific, and we can go for a DFA instead of a NFA. Now let's discuss about the steps of converting from NFA to DFA. Let M equal to Q sigma Q naught F, and the delta is an NFA which accepts the language L of M. There should be a equivalent language of DFA denoted by M dash equal to Q dash sigma dash Q naught dash F dash and the delta dash, such that L of M equal to L of M dash. Steps for converting NFA to DFA. Step 1. Initially Q dash of DFA should be equal to the phi. Step 2. Add Q naught of NFA to the Q dash of the DFA. Then find the transitions from that starting state of the NFA. Step 3. In Q dash, find the possible sets of states for each input symbol. If this set of states is not in the Q dash, then add it to the Q dash of the DFA. Step 4. In DFA, the final state will be all the states which contain F. F is the final state of our output. Let us discuss an example converting the given NFA to a DFA. And here we have the transition diagram of the NFA. Here Q naught is the starting state and Q2 are the final state, and Q naught, Q1, Q2 are the three states given. 0, 1 are the inputs. Now we have to draw the transition table for the transition diagram of the NFA. Now we have to take the states on the one side and the input 0, 1 on the other side. Now Q naught with 0 will as the input will stays in the Q naught, and with 1 as the input it goes to the Q1. Q1 with the input 0 it goes to the combination of Q1 and Q2, and with the input as 1 it goes to the Q1. Q2 with the input 0 it goes to the Q2 itself and stays there, and with input as 1 it goes to the Q1 and to the Q2 as the combination of Q1 and Q2. Now we have to go for the transition state of sigma delta naught of Q naught. Here we will get sigma naught with Q naught, and with 0 we will get Q naught. Sigma naught of Q0 with 1 we will get Q1. So this is for the delta dash of Q0. Now we have to go for the delta dash of Q1 as we obtained at here. Now sigma dash of Q1 with the output 0 we will get Q1 comma Q2 as the new state generated. We can take it as the new state generated. Now with the input 1 we will get the state Q1. Now we have completed with the Q0 and Q1. Now we have to go for the state Q2, delta naught of Q2 with the input 1. we will get the q2 delta naught of q2 with 0 with 1, we will get the q1 comma q2. Now we have completed q0, q1, q2, but we have generated a new state. Now we have to obtain the delta naught transition for q1 comma q2 also. Here q1 comma q2 of 0 is the union of the q1 comma q2. Here we will get q1 comma q2. For 0 as the input, we got q1 comma q2. For 1 as the input, here we get, because of delta of q1 comma 1, here we get as q1 and q2 comma 2, q2 comma 1 as this. So we have written like this. Same procedure, delta of q1 comma 0 is q1 comma q2. So and q2 comma 0 is q2. So we get the transition states here. Now we have to write the transition table for the DFA with the new states. 0 comma 1 as q1 q0 is the starting state. We have to take q0 q1 as we obtained at here. Now for the q1 with the 0 as the input, we will get q1 comma q2, and with 1 as the input, q1 as we got at here from. Now as q2 is the final state, we have to mark q2 as the final state. As q2 with 0, we will get the output as q2, and with the input q1, we will get the q2 with the input 1, we will get the q1 comma q2. Now we have to mark q1 comma q2 state as the final state because it consists of the q2, so it will be also a final state to the transition diagram. q1 comma q2 with the input 0, we will get q1 comma q2, and with the input 1, we will get the q1 comma q2. We just got these values from here. Now with using this transition table, we have to write the transition diagram for the DFA as we got q0 as the starting state, q0, then it with input 0 it goes again comes to the q2, so as the self loop. Now with the input 1, it goes to q1, and q0 q1 with input 0, it goes to one state, which state, q1 comma q2. So with input 0, q1 comma q2, q2, and q1 with input 1 it goes to the state 1, so it was a self loop. Now q2 with the 0 as the input, it goes to the q2 itself. So we have, and it was the final state, we have to make it as a final state. q2 with the input 1, it goes to the q1 comma q2. With the input 1 it goes to the q2, and q1 comma q2 with input 0 it goes to the itself, so it was a self loop of 0. Again q1 comma q2 with 1 as the input, it goes to the q1 comma q2, so both 1 and 2 are the self loops of the q1 comma q2. As q0, there was no connections for the q2, so we have to consider q2 as dead state. Now the final automata. q0 with 0 as the self loop, and q1 with 1, and it goes to 0, q1 comma q2, as q1 and q2 are the final states and they have the self loops 0 comma 1, but we just taken this as out because it was a dead state. Why? Because there was no incoming to the q2 state. No, so we just removed the dead state and we again created a new transition diagram. It was the complete transition diagram of a DFA. Now let's look at another example converting NFA to a DFA. Here q0 and q1 are the states and 0 comma 1 are the inputs. Here q0 is the starting state and q1 is the final state. On transition table, for the transition diagram, on q0 as the input, as q0 as the state and 0 as the input, we get the states q1 q0 comma q1, and as the input 1 we got the q1 as, and q1 as the state and 0 as the input, we got the 5 as the output, and q1 as the state and 1 as the input, we got the output q0 comma q1 as the output. Now we have to go through the same process which was explained in the first example. Now with the same process we have to draw the transition table for the DFA. 0 comma 1 as the inputs, and q0 q1 and q0 comma q1. Here q0 comma q1, here we got an extra new state, so we have taken it, and with this we have generated q0 comma q1 5 and q0 comma q1 q0 comma q1 q0 comma q1. q0 with the input 0 we got the q0 comma q1 as the output, and with the input 1 we got the q1 as the output. q1 state of with the input 0 we got 5 as the output, and with input 1 we got q0 comma q1 as the output. q0 comma q1 state of input 0 we got the output as q0 comma q1, and with the input 1 we got the output q0 comma q1. With the transition table of the DFA, we have to write the transition diagram for using this table. Now as q0 as the initial state we have to take as, and with the 0 it goes to the q0 comma q1, and it was the final state which goes to the 0, and it goes to the q1 with the input 1. So I have to take another one, q1. Q1 is also a final state. Now with the q1 0, it goes to 5. No, we don't take anything. Now q1 with as 1 as the input, it goes to the q0 comma q1 state. Now q0 comma q1 with input 0, it goes to the q0 comma q1. So it was the 0 as the self loop, and with the input 1, it again comes to the q0 comma q1. So it was the self 1 is also self loop. So here q0 comma q1 are the q0 comma q1 are the final state, and q0 is the starting state.